So give me some points that 2 to the x goes through. 0, 1. Couple more points. 2, 4. What about on this side? And what else do we have to draw? Yes, but just for this graph, what's missing? Horizontal asymptote. Where's the horizontal asymptote? And I'm just going to label this one because we're going to have 2 graphs on the same set of axes in a second. So that's 2 to the x. How do you know that's exponential? Variable is in the exponent. Now what we're going to do is just do the inverse of that. And how do we graph an inverse? So go back to unit 3 in your head. What's the deal with inverses? Switch the coordinates. Okay, so first one we plotted was 0, 1. If we flip those, we get 1, 0. Step ahead of me. 1, 2 is going to become 2, 1. 2, 4. 4, 2. And we had 3, 8. 8, 3. On the other side, we had negative 1 and a half. And we had negative 2 and a quarter. A quarter, negative 2. And if we have a horizontal asymptote and we flip it, what happens to it? It becomes vertical. So asymptote now is going to be on the y-axis. And so the inverse approaches it and goes down but doesn't cross it. And this is the graph of y equals log, which we'll talk about in a second. It has a little tiny base of 2, so that's a subscript, and then the variable x. We call that log base 2x. So almost every function has an inverse function, just like almost every operation has an inverse operation. And you started learning this back in grade 1. What's the opposite or the inverse of adding something? Subtracting. And then when you got a little bit smarter in grade 3, we added multiplication, and then we added its inverse, which is division. You practiced those for a couple of years, and then you got to about grade 7, and we squared stuff, and then we did the opposite, which was square rooting stuff. And that's what you've been doing your whole math career, because that's how we solve equations. We always do the opposite, or what's called the inverse. The inverse of an exponential function is called a log function. The inverse of an exponential function is called a log function. A logarithm, which is the long word for log, scares us because it's so many letters, is the inverse of an exponential function. So we're just going to talk about it today. We're going to look at some properties. We'll get into why we need it and how we use it a little bit later. Today we're just going to introduce and look at what it looks like and what are all its things and how is it cool. So now a question can ask you to jump straight to sketch the graph of y equals log base 3x. Log base 3x. Put your finger in the air. Show me an exponential function. What does it look like? Okay. Now you know what a logarithmic function looks like. Show me a logarithmic function. So it comes from the bottom and goes. So it's kind of like our square root swoop. It just also has a piece that goes down to infinity. Again, show me an exponential graph. Show me a logarithmic graph. Awesome. Okay, so jumping straight to the log graph, what we're going to do is actually first graph its exponential partner, and then we can just take the inverse. To get the exponential partner, I'm just going to grab the 3 and the x. So I'm going to ignore the log for a second, and we're going to say its inverse is 3 to the x. So if we graph that, then take an inverse, we end up getting the log graph. So now you know how to graph a graph like this. We're going to do tables of values in our heads, just like we did ahead. So let's put in 0. Let's put in 0, 1. And let's put in 1 and 2. And then on the other side, we don't worry too much. We know if we put in -1, we get a third, so it's somewhere down here. And if we put in -2, we get, again, we're not really caring too much about this because we know it approaches the x-axis, doesn't cross it, and shoots up. And I'm not going to draw that horizontal asymptote. Why not? Because I'm about to do the log graph and I have to flip it anyway. Okay, so step number 1 to draw a log graph is draw the exponential that goes with it. Now to get the log graph, I'm going to start by doing the asymptote. We know that it's got a vertical asymptote on the y-axis. And then I just need to take those points and switch them. 0, 1 goes to? 1, 3 goes to? 2, 9 goes to? And again, we don't really care what's happening with those other tiny values because we know it's going to approach the y-axis on the bottom. There's your first log graph. Questions so far? Show me the shape of a log graph in the air. I love Kelsey's like angry at these graphs all the time. That's awesome. The logarithm of a number is an exponent. The logarithm of a number is an exponent. Oh, sorry. Am I going too fast? Kelsey! You're in charge of domain and range. Domain. Brackets.
The parentheses bracket and then the actual bracket. Square it. No. Wait, no, that one's the other circle.
You're doing so good with the word parentheses. Why is this one round?
Because it doesn't include 0.
And why is this one round?
Because it's infinity.
Because it's infinity, infinity special. If you want to do the other notation, what would you have?
X is greater than 0.
Perfect. The range. And if we want to match this notation, or YER. So it's just backwards from the exponential. You have to be able to recognize both, so if it's in a multiple choice question, they'll mix it up. If you're stating it, it's your choice. Did that answer that question? Okay. Yeah. Yeah. But this comes super, super, super close, right? Because we have -1/3 and -1/9 and -1/27. So that's also smaller than 1. Logarithm of a number is an exponent. When you take the log of a number, what you're looking for is an exponent. If log base BC equals A, okay, follow me here, then B to the A equals C. If log base BC equals A, then B to the A equals C. What it means with actual numbers. If they give you log base 2 8, that's actually asking you a question without using all the words. It's notation. What that question is asking is 2 to the what exponent equals 8. Log base 2 8 is a question, and it's asking you 2 to the what equals 8. 2 to the what equals 8. So what does all of this equal? 3. That's what a log is. It's figuring out the exponent, giving the base and the answer. Okay? It's figuring out the exponent, giving the base and the answer. Again, if that's like, that's okay right now. What we're going to do today is we're going to take log expressions and convert them to exponential expressions. Then we're going to do the opposite, take exponential equations, change them to log. Then we're going to work a little bit more on that evaluating. So what does it mean? Then tomorrow we're going to do something called log laws, which makes me laugh, log laws. And that's going to tie to your exponent laws. And then eventually where we're heading with this, after log laws, eventually, oh, we're going to graph them, yay. Eventually where we're heading is these kinds of equations. What kind of equation is this? I don't know. It sounds like a wheelie chair. Oh, a cart maybe. It's not the computer cart. What kind of equation is this? Exponential. How do you recognize it? Variable exponent. Well, we did these yesterday, so why do we need to redo them? Okay, well, common base is what we did yesterday, so we look at the numbers and we try to change it into one, so we look at 40. And can we change 40 into a base of 5? So 5 squared is 25, 5 cubed is 125. Can we do anything with 40? So that's where we're heading, is to be able to solve the exact same questions as yesterday, but you can't find a common base. So for example, look at number 3. Is there any way to change a 2 and a 5 into each other? So this is where we're heading. It's why we need all the theory to be able to do these guys. Okay, so we're going to move from log to exponential. We're going to go exponential to log and then do some evaluating. If you're a wordy person, you move the base to the other side and raise the exponent. The log notation disappears. Move the base to the other side and raise the exponent. The log notation disappears. As a kid, did you ever play the game Sorry? Yeah. Okay, somebody who's played it, give us like the 5-second rundown. How do you play Sorry?
Pieces.
Yeah.
It's, I don't even remember. It's like a board, and then there's cards or whatever that tell you to move or whatever.
And the goal is to get all 4 of your men all the way back to the beginning, right? And what happens when you land on a square somebody else is already sitting on? It's the best part of the game. Yeah, like you're supposed to just casually lift them and put them back to their start, and you're supposed to say, sorry. But really, what do you get to do? Like flick their piece at them, right? And like, sorry! And you're like, you're not really sorry. That's what's going to happen here. The base is going to move over, but the 3's already there. So he's going to bump the 3 up and really not be sorry. The log disappears. So 3 moves over to the other side, bumps the 3 up. 27 stays exactly where it is. The log notation disappears. The base goes over, bumps the exponent up. Sorry. The log notation disappears. Now at first this is like, what? But you're used to seeing this. Does 27 equal 3 to the 3? Yeah, these are the exact same equation. They just look different. It's the exact same equation, they just look different. So for now, this is like, what? Craziness going on. This should look okay. So all we're doing today is just converting back and forth. But 3 squared doesn't equal 27. 3 cubed has to equal 27. Yeah, so if you put it the other way, that's fine. Yeah, yeah. If you have 3 cubed equals, that's fine. Okay, take a look at this one. Log, no base, 100 equals 2. Log no base 100 equals 2. Note, when you have, for example, 4x, what's the exponent that you don't see? 1. And if I just give you x, what's the coefficient that we don't see? So when you don't have a base that you, or you have a base that you don't see, the default base is? It's 10, yeah.
I knew that. I actually knew that. Should have asked.
I know, everything else is 1. This one happens to be 10. It's the little number, so we don't have a little number here. It's a little number. So we're just going to write it in for this one. So if you don't happen to see a base, it means it's 10.
Was that random or that was carefully chosen?
Carefully chosen. So again, what this is asking you, log base 10 100, without using the words, it's asking you 10 to the what equals 100. 10 to the what equals 100. 10 what equals 100? squared. That's why there's a 2 there. That's why it's equal to 2. If we go back up here, this is asking you 3 to what exponent equals 27? 3 to the what equals 27? 3, and that's why it's equal to 3. Okay, so if we want to convert this, 10 moves over. What happens to the 2? Sorry, not sorry. What happens to the 100? Stays, and the log disappears. So 100 stays where it is, log disappears, 10 goes over, bumps the exponent up. And what's nice about these is you can check, does 10 squared equal 100? Then you know you've done it the right way. Okay, I'm going to cover the answer. Log base 5, 125. That's asking you 5 to the what equals 125. 5 to the what equals 125. What's the answer? 3. That's why there's a 3 there. Okay, converting to exponential, base moves over, exponent bumps up, 125 stays, log disappears. Base goes over, bumps exponent up, 125 stays, log disappears. On the right-hand side, we have, and again, you can check it, because this makes sense to you, 5 to the 3 equals 125. If you have it backwards, so for example, 125 to the 3 equals 5, doesn't make sense. How are we doing so far? Good. Then they'll throw in these crazy ones where there's no numbers. Okay, so there's no way to check, so you have to really understand what's going where and what's moving. What moves? The base, which is P. Because P moved, what also moves? N goes up. What about Q? Stays, and the log disappears. Q equals P to the N. Try the next one all by yourselves. Log base AX equals Y. Bless you. A to the equals. What did I do there? I switched it. Does that matter? No, you can also have x equals a to the y. Completely up to you which is it. Who had that correct? Awesome. How are we doing so far? Okay. Now we're going to go backwards. So we want to go from exponential notation to logarithmic notation. Exponential notation to logarithmic notation. How do you know which is which? What's exponential notation? It has an exponent. What's logarithmic notation? It has a log in it. So if you're a wordy person, what's going to happen is we're going to move the base to the other side as a log base, and we're going to drop the exponent down. So it's just doing the opposite of what we just did. Move the base to the other side as a log base, drop the exponent down. Bless you. So the way I look at this is before base came, bumped exponent, sorry, not really sorry. Well, now the exponent's pretty pissed off because it doesn't want to be up there. It wants to be down with everybody else. So the exponent stomps on the 2 to bring itself down. 2 goes over to the other side. So exponent drops down back where it was. 2 goes over to the other side as a base. 16 didn't move. And what notation has to go in front? Log. Okay, so the base went over, became the log base, exponent dropped down. Let's just show why this is 4. What is this question asking you? 2 to the what equals 16? 2 to the 4, and that's why the answer is 4. Okay, what's going to move here? The 10's going to go over. Because the 10 moved, what's going to drop down? The 3.
And the 10 is going to disappear.
You're a step ahead of me here. Okay, so log's going to go in front. 10's going to become the base. 1,000 doesn't move. And the exponent drops down. But we would never write a base of 10 because that's the default base. So how would we write this mathematically?
Log 1,000 equals 3.
And there we go. No. No. Natural logs are all special. Can't talk about them yet. 28 to the 0 equals 1. What's going to move to the other side? 28. What's going to drop down? What's going to stay in its own spot? Write this in log notation. Okay. 0 equals. Confirm. Again, let's just talk about what this is asking. This wants to know 28 to the what equals 1. 28 to the what equals 1? How do you make 28 into 1? Because that's our zero exponent law. So anything to the 0 equals 1. Okay, try the next one where there's no numbers. There's just letters. So write this in log notation. Okie doke, give it to me. Is there another way you could have this written? Perfect. Who got it? Awesome. Note, and it's bolded. Log base n1. Doesn't matter if n is 2, 5, 27, 1,526,000. If you have anything here and this is 1, what do you know the answer is? 0, because anything to the exponent of 0 equals 1. If you have log base n of n, so the two numbers are exactly the same. So for example, log base 3, 3, log base 5, 5, log base 10, 10. What does the answer always have to be? 1, because anything to the exponent of 1 is itself. So those are just two ones that you can do quickly because you know that they're always going to be 0 and 1. Okay, so we've done exponential to log, log to exponential. Now we're going to do evaluate. Highlight the word evaluate because sometimes it boggles my mind, but students get to grade 12 and they don't know what evaluate means. So what does evaluate mean as opposed to solve? We've done calculate, we've done all these other words. What does evaluate mean? Dead silence, I love it.
Just say what it's asking, not actually do it.
Kind of. More specific, though. What does evaluate mean? It means find the numerical response. That's the actual official definition. Find the numerical response. What it means is they're looking for a number. Okay, so you're not going to have an X in here. You're not going to have other stuff. They want one single number when it's evaluate. Okay, so it's not converting it to another form. It's find me the number. What does this equal? So log base 216, we already did in one of the previous examples. This means it's asking you 2 to what exponent equals 16. So without all the words, this is asking 2 to what exponent equals 16. What does log base 216 have to equal? 4. And you can check it by converting to exponential and seeing if it makes sense to you. So if we convert to exponential, what's going to move? The base, what's going to bump up? The 4, what's going to stay the same? And the log? So there's converting to exponential, and ask yourself, is that true? Does 16 equal 2 to the 4? Then you know you have the right answer. Okay? You don't have to check. It's just a quick way on the exam. If you're feeling stressed and you want to make sure it's the right answer, convert to exponential. Log base 3, 9. Turn to someone in front, behind, beside you. Tell them what that is asking you. I love the talking to each other. It's lovely. What is this asking you? I heard talking there, I heard talking there. So if it helps your brain to write it out, then write it out. This is what it's asking. 3 to the what equals 9. So if you're visual and you want to actually see it, then write it. Once you see like that, the answer becomes pretty obvious. 3 to the what equals 9? 2. Now take a look at the difference between B and C. What's the difference? We're flipping them. So we want to know is, does that make a difference? So what is this asking you? 9 to the what equals 3. 9 to the what equals 3. Well, the only way to take a base and reduce it, what does the exponent have to be? Has to be a fraction. So if the base is bigger than the answer, the exponent has to be a fraction. Well, what would we normally put on this side to make it 3? What do you do to 9 to make it 3? You square root it, right? And what's square root in terms of a fraction? It's a half. So this is a half. Okay, so in your brain you're like, ooh, square root is a half. I'm just going to repeat that sentence in case you're a wordy person. If the base is larger than the answer, if the base is larger than the answer, the exponent is a fraction. They'll try to throw in this tricky one with no base, but you're smarter than that. You know what that imaginary base is. 10. Okay, what is this question asking? 10 to the equals, okay, 10 to the what equals 100? Oh, fraction, ooh, okay. This is asking 2 to the I don't know equals a quarter. Well, you already know from your exponent laws, if the answer is a fraction here, what do you know about the exponent? It had to be negative, so I'm going to repeat that. If the answer is a fraction, the exponent is negative. If the answer is a fraction, the exponent has to be negative. So we know it's a negative, we just have to figure out what's the number. Well, what turns 2 into 4? Negative 2. There's all the possibilities. It's going to be a whole number, a fraction, or a negative. How are we feeling so far? Whew. Let's put a lot of this together. Okay. What is this asking? 4 to the what equals 1 on 32. WTH, what the heck? Nothing 4 to the nothing equals 32. So 2, or 4 squared, sorry, is 16. 4 cubed, 64. How am I going to get 32? Well, if I gave you nothing else, forget all this log stuff, forget everything, pretend we're in class yesterday, how would we have solved this? This is a common base question. It's exactly what we did yesterday. What can we turn 4 and 32 into? 2. So I can change this into 2 to the 2. And I can change 32 into 2 to the 2 times 2, 4 times 2 times 2 times 2. So that was step 1 yesterday, convert to common base. What was step 2? Simplify using exponent laws. Okay, exponent law on the left says we need to do what with those exponents? Multiply, so this becomes 2 to the 2x. Fraction on this side says we're using our negative exponent law, so this becomes 2 to the negative 5. How do we know when we're done simplifying? Both one base, no fractions going on, cross them out. X equals. Okay, so if you get a base and an answer that you can't link together, it's a common base question. It's just a question from yesterday. Oh my God, geez, as hard as it's going to get. What is going on here? There is roots, there's a 3, there's a little 2. Always go back to what is the question asking you? 2 to the what equals the cube root of 4. Okay, how would we have dealt with this yesterday? Okay, so what do you want to change around? I heard negative 3. 1 over 3. Confirm? Yeah, I'm just going to do that in the next step. I'm just dealing with that exponent at this point. So now we can take 4 out and we can put in. Simplify. Slash slash x equals 2 over 3. Okay, so when you get crazy ones, they're just questions from yesterday. It's why we did yesterday's questions. Last one, turn to someone in front, behind, beside. Tell them what this is asking. Thank you for talking this time. What's the question asking? 2 to the what equals negative 4.
Which you can't really do.
Why?
Because you can't do anything with an exponent to turn a positive into a negative.
Okay, so we talked about this 2 days ago when we did the graphing. If we put in a whole number, we're going to get out a positive. If we put out 0, we're going to get 1. If we put in a negative, we get a fraction. Is there any way to get an answer of negative 4? So this is undefined. Note, clearly important. The answer here can't be negative, ever, ever, ever. It's impossible. What else can it not be? 0. Why could we not have a 0 here? So 2 to the what gives us 0? Why not? Because that's where your asymptote is. So you cannot call it taking a log. It's like taking a square root of a number. You cannot take a log of 0 or a negative number. And if you're a picture person, that's because of the horizontal asymptote and the fact that the graph is all above the x-axis. So nothing exists underneath, nothing exists at 0. That's going to come back to haunt us a little later on, so you'll hear me say about a bajillion times you cannot take the log of a negative number. Whew, we're half